Okay, this is my video reassessment for the collision standard. The question I chose was, a movie production set sets up a head-on collision between a small 780 kilogram car and a large 2,300 kilogram bus. The bus initially moves at 22 meters per second and the car at 26 meters per second. If the two vehicles collide and stick together and move off at a shared velocity, how much energy was lost in the collision? So first, if you find the momentum of each, so P1 plus P2 equals P1 plus P2, which breaks down into MV1 plus MV2 equals MV1 plus M2 V2. So if you plug in the information and given, it's going to be the 2,300 kilogram times 22 meters per second plus the 78 kilogram times the negative 28 meters per second, because this car is moving in the negative direction, and that equals the 2,300 kilogram plus the 780 kilogram times the velocity. So if you solve for V, it's going to equal 9.84 meters per second. So after you find the velocity, you have to use the formula for kinetic energy to find how much energy is lost. So if you have the 1/2 mv squared plus 1/2 mv squared, it's going to be the 1/2 times 2,300 kilograms times 22 meters per second squared plus 1/2 times the 780 kilograms times the 26 meters per second squared to give you 820,240 joules, and that is before the collision happens. And after, it is going to be 149,111 joules plus the lost energy. And you set this up as the total kinetic energy in the system. So you would use the two masses of the cars added together times the velocity found from the momentum. So if you solve for the lost energy, it would be the 820,240 joules minus the 149,111 joules to equal the lost energy of 671,129 joules.